Okay, rational inequalities. We only got 2 examples, so let's jump into it because these take a little time. So I'm going to kind of give you some steps for solving a problem like this, but I'm not going to really write them out here. Just kind of follow along, and maybe I would jot them down in your notes if I were you. But the first thing we want to do is we want to make our inequality with a 0 on one side. So if I have 5 over x plus 4, actually, let me back up a little bit. I would want to get everything onto one side of the inequality by subtracting 2 from each side. So I'd have 5 over x plus 4 minus 2 is greater than 0. No, all I did was subtract 2 from each side. So my first step is to try to create a 0 over here. Then what I want to do is I want to create one term, one fraction over here on the left side of my inequality. So I need to create a common denominator. Okay, so if I have 5 over x plus 4 minus 2 is greater than 0, you might think, okay, what does this need to have the same denominator as this? And you say, oh, well, it needs an x plus 4. So what we do is I've laid out in different videos, we multiply by our fancy 1. I'm going to multiply by x plus 4 over x plus 4, which is what I call the fancy 1. And by doing that, what we end up with is this. We have 5 over x plus 4 minus 2 times x plus 4, also over x plus 4. In fact, let me do that in 2 different steps. I don't want to skip a step and confuse somebody. So 5 over x plus 4 minus 2 times x plus 4 over x plus 4. And then now that I have that common denominator that I'm looking for, I can write that as one term. 5 minus 2 times x plus 4 all over x plus 4. And then let's just simplify in our numerator real quick. If I were to distribute the 2, we'd have 5 minus 2x minus 8 over x plus 4. And then my last step would be I would combine, oops, that's an eraser, not a highlighter. I would combine those like terms right there, and that's going to give us what we want. And I'll kind of come up here to copy that. That's going to give us negative 3 minus 2x over x plus 4 is greater than 0. So all we've done so far is a bunch of algebraic manipulation to turn this into this. Now, here's where we actually deal with the fact that it's an inequality. We want to know, where is this greater than 0? In other words, if I were to graph this, where would this be positive? And our first step is that we want to find the critical values. Critical values. Okay? And the way we do that is we're going to do that by setting the numerator equal to 0 in solving, but we're also going to set the denominator equal to 0 and solve. So here, let's see, I would add 3 to each side, then divide by negative 2. So x would be negative 3 halves. And then over here, I would just subtract 4 from each side, so x would be negative 4. And here's what these critical values mean. I'm going to picture them on a number line, okay? And we've got, let's see, I'm going to have a random 0, but I don't have to have it, but we have this could be our negative 1.5 or negative 3 halves, and this could be our negative 4. And what that leaves us with is 3 gaps. I've got a gap here, and a gap here. Because what happens at those critical values, that would be a situation in which this rational function, if I were graphing it, could go from being positive to negative. It might be a 0. In fact, let's see. This would be a 0 of the graph. It's where we cross the x-axis, and this would be a vertical asymptote. I know we haven't talked about that yet, but that's what those would be. So basically, these would be our points in which this could flip from being positive to negative or from negative to positive. But all we do now here is we just do a guess and check. I'm going to substitute in test points, and so I'm going to pick one that's to the left of negative 4, and hey, how about negative 5? Then I'm going to pick one that's in between these two, one that's in between negative 1.5 and negative 4. How about a negative 2? I'm going to pick one that's over here that's a greater value than negative 1.5. Well, 0 makes for easy math. So what I'm going to do is I'm going to evaluate my function at these test points if I were to think of it as a function. So let's do f of negative 5. In other words, we're going to put a negative 5 into our function. Negative 3 minus 2 times negative 5 over negative 5 plus 4. Okay? But we're going to do the same thing with negative 2 and 0. So let me kind of write that out. This is what we got. So I substitute negative 5. Let's see. I don't even really care about the value of this. I really just care if it's positive or negative. Okay. So let's see. That would be a positive 10. Negative 3 plus 10 would give us 7 in the numerator, and our denominator would be negative 1. I don't really care that this is a negative 7, but what I do care about is that it's a negative. Because what that means is that means all these values in here are negative. It doesn't matter if I put in negative 5, it doesn't matter if I put negative a billion into this, it's going to give me a negative answer. And then let's kind of do our second value. If I substitute in negative 2, we're seeing if we're positive or negative in this little gap. And it looks like that would be a positive 4, negative 3 plus 4 would be 1. And our denominator, negative 2 plus 4 would be 2. And once again, I don't care that it's 1/2. I really just care that it's positive, because what that means is this gap right here, any value in between negative 4 and negative 3/2 would be positive. And let's do our last one. Let's see, negative 3 minus 0. That's going to be a negative 3 in the numerator and a positive 4 in the denominator. Hey, we got negatives over there. So let's interpret what this means, okay? What this means is that I'm looking for where this function is greater than 0. In other words, where is it positive? And what we can see is it's positive in between negative 4 and negative 3/2. So our solution here is going to be, if I wrote it in an interval notation, it's going to go from negative 4 to negative 3/2. This is an inequality. You could write the same thing as an inequality. But that would be our solution. We need to do one more for practice. That's a lot of steps. Let's do one more. Okay, so we're looking at this one. This video is going to be a little long, but hey, that's okay. We're learning stuff. So I'm going to play the same game as last time. Okay, I am going to first rearrange it. So I've got my 2x minus 1 and my 3x plus 4, but I'm going to subtract 5 from each side. And once I subtract 5 from here, it becomes a 0, and once I subtract 5 from here, we got this. Now I'm trying to get that common denominator. And so my common denominator is going to be 3x plus 4, so let's multiply by 3x plus 4 over 3x plus 4, which is our fancy 1. Okay? And now I'm going to copy down what we have up to this point. All right, so I got that copied down. So what I'm going to do next, and I'm kind of skipping the lower level algebra, I'm going to distribute, and then I'm going to combine like terms. Okay? And so once I do that, I should have this. So once again, I just took this numerator and did all the algebra to simplify it by distributing and combining like terms, and you should end up there. Now, we are to the point where we are ready to find the critical values. So to find our critical values, what I'm going to do is I'm going to set my numerator equal to 0 and solve, and I'm going to set my denominator equal to 0 and solve. Well, if I solve this numerator, I'm going to add 21 to each side and then divide by negative 13. That's going to give us a 21 over negative 13. That's one critical value. If I take this second one and I subtract 4 from each side and then divide by 3, we should get negative 4/3. Now, what we do with those critical values is we're just going to put them on a little number line up here. We've got negative 4/3, which is kind of like negative 1, or not kind of like, it is negative 1.3 repeating. And then we are going to do our other one, which is negative 21 over 13, which I don't know what that is. I think that's, I did this one earlier. I think it's like negative 1.6-ish, negative 1.6-ish. And that's just to help us kind of find and pick values. And so what we're going to do now is we're going to do our test points, and we're going to pick a test point in each of these gaps. Okay? Over here, I need a number that's less than negative 1.6, so how about a negative 2? Here's one that's a little bit harder. I need a number in between negative 1.3 and negative 1.6. How about a negative 1.5? That's a pretty small gap. And then lastly, let's pick a number that's greater than that. How about 0 for easy math? Now, what I'm going to do is I'm going to take each of these values and substitute them into this right here to see where is this positive and where is this negative. Because what we're looking for is where is this negative. We want it to be less than or equal to 0. So what we're going to do is we are going to do f of negative 2. And because I'll start with this one, and I'm going to substitute into this expression. So what we're going to have is negative 13 times negative 2. And then we're going to subtract 21, and that's going to be all over 3 times negative 2 plus 4. Now I'm going to do the same thing with the negative 1.5 and the same thing with the 0. So let me write all that down. Okay, I've got my 3 test points. I substitute them to the kind of rational expression here, here, and here with my 3 test points. The next thing I'm going to do is I'm just going to do a whole bunch of calculator button pushes and figure out what these are. Remember, we don't really care what the values are. We just care if they're positive or negative. And here we are. So I did all that math with the calculator button pushes, and what we see is this. Don't care about the number, just care that that one's negative. Don't care about the number, just care that this one's positive. And I just know that because a negative over a negative is a positive. And then this last little category is negative. So if I'm to come back up here, and we've got our negatives, we got our positives, and we got our negatives, we can see we're looking for where this is less than or equal to 0. Now let's worry about the less than. I'll talk about the or equal to in a minute. That's a little extra wrinkle here. But where this function is less than 0 is going to be from negative infinity up to this point, and from negative 4/3 up to positive infinity. So as an interval, if we started at, I'll write my answer in purple. I haven't used a whole lot of that color yet. So our answer could be negative infinity up to negative 21/3. And I'm going to put that as a parentheses now. I'll talk about that more in a second. And from negative 4/3 up to positive infinity. Now, the only thing that changes with this or equal to, or I should say, or this or equal to, is that our answer could be 0 itself. So the question is, what's happening exactly here? Is there a spot where it's neither negative nor positive? Is it exactly 0 here, and is it exactly 0 here? Okay? And so what you would find is that this negative 21/3, if you put it into this expression, you would get 0 over something. Basically, this is a 0 of the graph. It's a root because it's where the numerator is 0. It's where our graph crosses the x-axis. In other words, our function is equal to 0 at that point. Now, the thing is, could you do the same thing here with this negative 4/3? What happens with this negative 4/3? Well, negative 4/3 is actually the value that made our denominator 0, okay? It's the value that made our denominator 0, so we actually have to throw it out. That's where an asymptote is. Our function's undefined there, so I wouldn't include it. I would leave my answer like this with the parentheses. So I realize that's a tricky little trick that we've got there, why this value is included and this one isn't, but it's because this one makes the numerator 0, so it's okay if we're equal to that value, but this one makes the denominator 0, and we can't have that. That's an undefined value, so we don't include it. That's why we show the parentheses there. But this video's getting long. Just to summarize, just follow these basic steps. I hope I didn't confuse you with that little bit at the end, but we are going to collect all of our terms onto one side of the inequality, get your common denominator and simplify, then find your critical values by making the numerator 0 and the denominator 0. Once you've done that and found those critical values, pick test points in between them, and then actually work those out in the expression itself just to figure out where it's negative and where it's positive. If you know where it's negative and where it's positive, then you should be able to answer this question where this thing is less than or equal to 0, because in this case it would be where it's negative.